this is hopefully will be good. Okay.
Can I turn my camera off since you're going on YouTube?
Okay, it's up to you for sure.
Thank you.
Hi, Jaya.
Hi, Jaya.
Okay, still the mic is not connected. I have 2 points I want. Maybe the whole session it will be about them. The first one is I want to remind all the people about where we start and how we start. What is our target in this class? So I will share my screen to one image only, just to tell you this was our initial plan. We are talking about machine learning pipeline in production. That means what is the activities that can lead us to reach to our model to put them in the production, and what is the concern that we have to focus on. We spend a long time in this step, which is prepare data. Okay, now this is not wrong because this is the target at the end. If we have good data, we have good results. But whatever we perform at the end, we have to consider 2 points. The first one is we have to choose our data processing functions to create them as a pipeline for our model. Why as a pipeline? Why as auto-triggered functions, let's name it? Because this will serve the model not only while creating or building the model in the first time, but even once it's in the production, according to the monitoring and according to the serving data that we receive. It's very popular, it's very frequent that the model need to be retrained, and according to the task, we have to decide how, when, and how to retrain it. And according to that, our data processing pipeline, most probably it has to be ready because the retraining, it has to be on fly, let's name it, on site. The model cannot stop working. One day we will replace the model with the new trained one. And according to that, no time for planning again. This is operational. It has to become operational method. Now, this is the first thing I want to highlight today. Why? Because starting from the next session, we will go to the model building, to the modeling processes, and how we can use all of these techniques on data processing to provide good data to our models. Now, the modeling in machine learning and deep learning, and maybe since I will be focusing on the modeling, I will be the teacher at that point. So the modeling, there is some examples related to deep learning because it's something I like it a lot. I found it's very effective way to do the tasks. So yes, data preparation, data pipeline building is very essential. Now, from where we can go from this, since we have our data cleansing, data transformation, scaling, all of this, it's performed. We know how to perform it. We find a way to do it. All the functions, you can find it on the GitHub repo. But at the end, we select for our task a set of data preparation functions, and we use it as our pipeline. Now, it's very important that the pipeline is related to task. It's not something that we can consider to always do it like this. For this task, I can use this transformation. For another task, I will use another one. Data cleansing, it's depending on the data source and the data generation method. So according to that, the data cleansing for this task, it has to consider, and here is the point, we not only considering what data set that we have to consider also what kind of data will be generated according to the model usage. Why? Because this will control our data pipeline, data preparation pipeline. Now, this is the first point that I want to highlight. I think it's good to remember the engineering part of our class, not only deep diving on the math and code. Now, what is the both consideration? This is what I want to highlight. First, what is the data set, our data set, training data set, how it's generated. The second, which is very important, what kind of data we are expected to come from the production environment. Because this data, it will be evaluated, it will be used to evaluate the model to check if we have any data drift or concept drift. If you remember what is the data drift and concept drift, I don't want to ask anybody. Okay. And according to that, when we are going to retrain the model and what kind of data processing also needed or data preparation needed before retraining the model. Now, this is the point I want to just remind everyone about it because it's playing major role for the modeling. The other point related to the modeling, it's how it will be deployed. Sometimes we are able to build a great model, but it's not suitable for the task. How to explain this? For example, I'm just trying to, okay, since I'm sharing my screen, I cannot see anyone. So if you have, if anybody has a question or something, you can use the hand raise or can immediately jump and ask me. So no problem with that. For example, if we are talking about autonomous cars, for example, as a task, at that point, we are not expecting that we have a cloud-based modeling that detecting the object on the street and detecting anything related to that, who's the, let's say, a human, or what's the signal, or what is the tree, or whatever, because we cannot trust the connection and how it will be. This task has to be performed on site, has to be performed on the edge. And once it will be performed on the edge, we are not expecting a huge computational capacity for that. And according to that, this task has to be, this models has to be prepared in a method. Maybe it will be small models that performing small tasks, and all of them together ensembled toward one thing. Now, this is toward the original task. This is also controlling our modeling method. At the end, we are not building, we might not building one model according to the data that we prepare, because we have to understanding the business back again, understanding the business is controlling that. On the other hand, sometimes it will be, no, it's much useful because the time is not critical. We don't have to make a decision within a millisecond. We still have minutes to make a decision, but at the end, the decision has to be very, very accurate, and it can be very accurate using huge models, just like deep learning models. At that scenario, it's better to accept the time of running the model, accept that time, because the result, it will be more important. Where we can find this, most probably in 90% of the healthcare, AI in healthcare models, because the time, most of the time, we still have 1 minute and more to make decision about anything, but the decision has to be very accurate. So all of this we can find starting from maybe next week, how different kind of tasks it's decided, how we can choose our model and our training and learning method. Also, one of the consideration we have to keep it the ability of sharing the serving data, because most of the time we are able to push the model to the production, and we need to evaluate the model according to the serving data, monitoring it continuously, but maybe there is some regulation that prevent us from using the serving data to retrain the model. That means centrally, to retrain it centrally. Now here, what we are going to do, this is some concept just like federated learning or knowledge distillation or something. We can go in the high level related to that, and especially federated learning, it's a very unique idea that you are building, let's say, on the edge also, separate models that help you build a central model or something like that. Federated learning, it can be a solution for data sharing issue, beside keeping also the model performing in a good way always. So this is something also we will make a session related to that. Maybe it will be the week after next week. So within 15 days, we will discuss about that. Why all of this is just to highlight that we go in depth for data preparation. Now we have to go out and check again what is our original plan and why this class had started, and what is the data-centric approach for machine learning pipeline. Anybody has a question here? Oh, no question. Guys, I cannot see anything. So if there is no question, tell me no question.
From my side, thank you.
Okay. Now this is the first point. The second point is related to the second image for today, which is this one. Now, sometimes I receive this question. It's related to two things. Why deep learning is effective? Okay. Jonathan, can you answer this question?
Why is it effective?
Yes.
Oh. That's a good question. Why is
At the end, I'm not asking for academic answer, high level
No.
understanding about it only.
Because you don't need to have a big data set to be able to do the deep learning because of the way it filters through it, through the layers.
In fact, this is not the fact. You need a huge data set, very huge
Opposite.
data set to perform it. Yes, exactly. This is why it's deep learning. You have a huge data and a huge structure, huge model, which is deep model. Now, the first, and I think it's important point you have to highlight. It's when you have this multi functions happening, which is the nodes of or the building units of the neural networks in each layers and over the layers. That help us to define non-linear relationships and all of the combination related to that. Why this image here, it's showing 10 linear relationships between input and output. Each one, it's only a line, you can see it here. Now, just if we check the outline here, this slope here, this 10 linear relationship showing us a possibility for non-linear relationship, which is appeared on the outline, on the slope, the outline slope. Now, this is what deep learning is doing. Each unit, each neuron, whatever you can name it, it's defining a linear relationship. Once we are talking about multi-layers, multi-nodes, at the end, we are able to define the non-linear, even if it's very complicated non-linear relationships. Let me check the chat. Another image. Which one?
Oh, so Guide, the image that you're talking about, the neural network, are you showing a different picture for that, or are you just explaining it?
It's no, it's the same. This one with 10 X and 10 Y values. This one only.
Okay.
Okay.
Because
just consider it like this. This blue line here, what it's explaining to us.
And then we got a different picture.
Yeah.
Sorry. It's not shared. Well,
no.
Just a minute. Let me reshare it. Okay. This one. I think you got it now.
Yeah, we can see it now.
Yes, we can see it. Thank you.
Now, each line of this, it's a linear function. This is what I'm trying to explain. But at the end, this slope, the outline, this one, okay, at the end, it's non-linear. And how we can define it? By mixing the 10 linear relationship between the input and output. Now consider this as hundreds, thousands, million of linear functions working together to check the relationship. This is what's the deep learning. That's why there is main factor here that whatever was the relationship, it was able to be detected, even if it's not there. By the way, this is something very dangerous. I can build a data set and tell you, okay, please, can you tell me what is the, for example, if this patient have a COVID from his eye colors, for example, and you can find it. Deep learning can do that. Even if there is no relationship, can be built this link. Okay, but at the end, if there is a real relationship there, it's very permissible to be detected. Now, this is the positive part. The negative part for deep learning, it's beside this slope that we are looking for in our graph here, we have multiple other relationships are already detected. Now, this is let's say, huge consuming for the computational power, for training model, for time of training, for cost at the end. So that's why also in this, there is new methodologies followed just to reduce this effect. Okay, so also we can discuss about that in maybe after 3 weeks. So I'm just giving a plan for the coming 4 weeks. So this is why deep learning is effective. Just think about it. We are trying to do our best toward preparing our data just to go and check a method, machine learning algorithm, whatever it was, to detect, make prediction about our relationship. Deep learning is able to detect that using, for sure, the gradient descent and all of this method. This is the power of deep learning. At the end, this is really why we need a huge data set and a huge structure to be trained, because we are dealing with open space, a lot of dimensionalities to detect any kind of relationship between the input and the output. That means it will be very expected to build a very powerful predictive modeling. So this is the point
I have
that
a question here,
yes.
Gabe, if you don't mind. So when we are like thinking of, okay, we want to apply deep learning in this data set, and is there a possibility to go with the PCA and TSNE just to kind of like reduce the data set as much as we can, and then do the neural network, so we know that, okay, there is a high probability that we're going to get this type of results. And there is like that kind of the black box idea of that neural network is kind of like, okay, diminished a little bit. Is there a possibility to do all these things, because it's a huge data set and we don't know which variables and which attributes are so important in our model?
You come with the answer, really, yes, for sure, because this is followed, by the way. It's not a lot of times we are doing that. Not only this, not only the testing, we are using other methods just to define. By the way, I couldn't find a practical example where we are going to deep learning immediately. Maybe unless if we are dealing with images, for example, maybe in medical sector, because I'm working on something similar. When we are processing X-rays or any kind of radiography, yes, here most of the time we are going to the deep learning immediately, but it's not expected to go directly to build a deep learning model for your task. But a lot of the times it will be after you understand your data in a good way, you understand what is the most effective features. One of the ideas comes from some friends that always build a multilinear regression models just to check your features and what is the most important features. It will help a lot. And then after that, to build a powerful predictive model, let's say effective predictive model, you can go to the deep learning. But yes, it's not expected to go immediately to the deep learning techniques.
Great. Wonderful. Yeah, got it.
So this is my ideas for today. As I told you, I'm not prepared to make a session today, but I found that this is what I'm planning for the next 4 weeks. So unless maybe next week Tom still have a session related to the principal component analysis, but in case he want to do it, it will be next week with Tom, and then another 4 weeks about the concept that we discuss about. Otherwise, starting from next week, I'm going to check the modeling part of the class. Oh, Tom is here.
Hey guys.
Hi. I will stop sharing because I want to see you. Happy birthday once again.
Hey, thanks, guys.
Happy birthday.
I'm sure the class is doing great. Hi, guys.
Good to see you.
Good to see you all. I'm just going to listen. I'll put on mute so you don't have to hear the road noise.
No, mainly if there is any question right now, Tom, because I'm not 100% ready for the session, so I just share some ideas with the guys. Okay.
Oh,
And
good.
now I'm going just to, if there is any question or any deeper discussion that we want to speak about, it will be very nice. But I think, Jonathan, yesterday you didn't join us. Or did you join
No,
us?
that was correct because of how I was feeling. I've just stayed away from it altogether.
So it's a good chance for Jonathan to say happy birthday to Tom also.
Yeah. Happy
Oh, there we
birthday,
go.
Tom.
And me, and me.
Thank you.
Sure.
Sorry, I was just trying to say that I'm going to go on mute and listen for a while because I haven't been following y'all yet. But if I hear a question, I'll try to answer if I can.
Okay.
Hi, Tom. Can you hear me all right?
Yes, I can.
This is Ngozi. Happy birthday.
Thank you, Ngozi.
Came specially for you.
Awesome, awesome. Just so everyone knows, this was the weekend I was supposed to do the big honeydew for my mother-in-law. We're going up to paint a shed. My father-in-law died a few years ago, and we try to all chip in and help out Sue's mom when we can. So this is our weekend to do a big project for her.
That's nice. That's really nice.
Okay, I'll let y'all get back to class. I love you all. I'm going to listen in. I'm going to go mute.
Oh, why don't you sit
Bye-bye.
and relax? Why don't you sit and relax? Guy will handle it.
Yes.
It's
Sorry,
missing
you
us
get
too much.
I think so. I think so. It is not safe for Tom to drive and talk. So it is better
Yeah.
Tom to drop and
Yes.
Guy will handle
Listen,
it.
guys, foul. I have a wife that treats me like a mom. I don't need all my kids in integrated doing the same. I promise not to wreck.
Okay. By the way, there is something I want to announce for here and in the mentoring. Starting from during the coming week, I will forward to you new invitations because we are going to stop using this current account of deeplearning.ai for the Zoom meetings. We have right now our own account, integrated MLI account, and I will forward to everyone new invitations. So starting from next week, please update your calendar, your links, all of this information once I forward it to you. This is
Okay.
yes, Ammar.
I think you could cancel the event from your side, so no one will have it anymore on his calendar.
Yes, sure. I will cancel it first and forward the new invitation. Exactly.
And I wanted to say happy birthday to Tom. And one more thing, that the code says don't text and drive. He's zooming and driving. This is something else.
I think this is acceptable at that. and we can trust Tom. He has the skills to do that. Okay. So guys, if there is any question, please let's have the discussion about it. By the way, also Ammar, he's a great person. So if there's some question, maybe I couldn't answer it, he can jump and help me with that.
Oh, this is intimidating.
No,
So,
this is
I have
this
a
is
question
entrapment,
here,
by the way.
Kate. Yes. Okay. Since I'm here, you will always be loaded with all the questions.
Yes, don't worry.
Okay. So it's a dumb question, but I just wanted to make sure I understand this well. So regarding the missing values, I know we have already done a lot on missing values in the simple regression, linear, logistic, everything. And we handle it quite appropriately by doing the mean median mode, sometimes doing the predictions. How does that work in deep learning? Like, do we do the same methods or while doing data preparation, or there is something that we can do differently during deep learning because of the huge data sets that we have here?
No, there's sometimes we are following the same, sometimes we are accepting the missing values. It's depending on, let's say, the case that we are studying and how we are processing our data. Yes, sometimes it's acceptable to have missing values in deep learning, but it's depending on the percentage of the missing values, let's say. But when we are going to make kind of imputation or something, it will be the same in machine learning. At the end, deep learning, it considers a special case of machine learning. So for missing values, it's the same strategy. It's followed
Okay.
the same things. Yes,
Okay.
If you want, I can add over this.
please.
Charma, are you interested in some details?
Yes, definitely. I'm always up for that.
So I think whenever we talk about CNN and deep learning, we talk about features, and there's something called feature correlation and feature importance. So it depends how important is that feature that has some missing values into the contribution of the overall like production aspect. Like, I mean, not production, but actually how much does this feature gives to the final decision making? How important is it to the final decision that is being taken? So if it isn't that important, if it doesn't contribute a lot, so one of the methods that is used here is to fix all the features and start toggling one feature, and at the other side looking at the accuracy. So when we toggle one feature and we look at the accuracy, it depends. Like if we toggle the feature from 1 to 100 and the accuracy doesn't change, so that means that this feature doesn't have so much importance into the model. So in this way, we could choose which feature to find, so like which features from the ones who has missing values we want to find solution to. So if this feature that has missing values does not contribute a lot into the final decision making of this, that means that we don't need to bother to look for solutions. Do you get me?
Okay. Yeah, definitely. So
Now-
you're saying we can simply run a regression and take that as a target variable and try to see how much accuracy we get on that, depending on the other variables. And then from there on, we can decide how we want to treat that.
Yes, but Ammar,
Yeah, I was gonna add into this. Don't always be fooled about the accuracy. You need the best generalization as well.
Exactly.
So don't get hung up on this variable has a better accuracy. Always
Okay,
try to get
okay.
that general picture across
Actually,
it.
I just want to share with you guys one table that I have done during the process of analyzing a model that I did. So if you're interested, I'm gonna just
Share your screen.
Show you the table itself, because it is like the overall project is under NDA, so I cannot show that much. Okay.
Okay, you can share your screen if you want to
Yeah.
that table exactly.
Okay. So so this is the table. You can see the classes here: building, road, vegetation, tree, and car. So, and this is the accuracy of each one of those. And we have an overall accuracy. We see the recall, precision, K, F1 score. So all of those are metrics, and it depends on, like, ignore the architecture. It depends on, as you all know, there's methods to calculate these things, like true positive, true negative, false positive, and false negatives. And it depends on the application itself to assess how to choose the one that you need to follow. So yeah, Jonathan, you are completely right. We cannot stick to accuracy at all, and it is not representative. But like I personally look at these tables. I made actually a function that outputs all of those, and at the end, if you see like one of those, for example, let's say vegetation in here has 71%, while building has 92%. So if I want to do something about my data, I need to work on the vegetation, for example. This is what I need to improve. And this is here is where accuracy works well, because it helps with lowering the bias. And oh, I just find out. Okay, sorry, I cannot share this. I'm sorry. Okay. Please, if anyone took a screenshot, it would be bad for me.
Okay.
So
can I but just add something here? Ammar, I agree with all, and Jonathan also, with all what you said, but only I have one concern. When we are talking about deep learning scenario, this is very costly to perform that. Time cost, let's name it at least. So That's why there is other method we can do. I agree with the feature importance idea. Yes, 100%. We have to check this one. But here, I think it's better to build your model and then go maybe use Lime or Chop or any kind of other XAI techniques to explainable AI techniques to understand the feature importance and find where you need to make value imputation for the missing values or something like that. This is just kind of from practicing this. In deep learning, what you are explaining, I think it's it costs a lot to perform. Correct me if I'm wrong.
It does cost a lot, yes. But if you are going towards a deployment scenario, cost is fine because you are deploying something.
Okay.
Right? Because you care about the user experience at the end.
Yes, but if there is a method, here is the only point. As I told you, if there is a method can help you to reduce that cost, which is again explainable AI technique, which is, believe me, it's something very nice to use. It's give you great idea about the feature importance after training the model, and it will help a lot.
So we are talking about a technique that reduces
exactly, and this is the only thing. No, it's the same. By the way, it's the same. The job performed at the end, it will be the same.
Okay.
Just only which steps you can follow. That's the only thing.
Like a systematic way of doing what I did.
Exactly.
Okay, makes sense. And yeah, it's good. It's way better, and it doesn't apply for my case because I'm in research. But yes.
Yes, I get. Now this is the difference between someone like me who's just fighting on the production life and the researcher like Ammar. Okay. Yes, who's asking?
This is Jay. What is explainable AI? You just mentioned just now.
Okay. Explainable AI, it's machine learning in general and deep learning in special. It's just like at the end we are dealing with a kind of black box model. We have input and we have output, and we can find using all the matrices that we follow for evaluation. Okay, the model is doing good, but why? We don't have a clear answer about this question, why it's doing good. We can say, okay, it's doing good because this is our data preparation method, this is our data set, this is the distribution of the data set, so it's expected to create this relationship between the input and the output. But still, we don't have a clear clue about why. I will give one example. If we are using many images that showing horses, for example, in classification model to tell what is in the image. Okay, is it horse or not? Let's keep it binary. Okay. Now, when we test the model, we found that it's predicting well that when you pass a horse message, it will tell you that this is a horse. But why? Now, in explainable AI, there is some issues appeared before talk about the explainable AI. I'm talking about the need of explainable AI. There is some issues appeared, which is, for example, according to the data set that we use, we find that the why is not related to a real reason. There is no real cause for this relationship. For example, again, for this horse image task, sometimes it was the script related to the image, which is telling you, okay, this is in which date or something. It was the main reason of classifying the image that this is horse or not, because they are use all the images from the same environment or the same generating method. Now, in this way, we are not detecting that this is horse. We are detecting that this is image with special script. Okay. Now, this is not the task that we want. Even if the evaluation matrix told us that, okay, you are almost very accurate about your task, but once we receive a new data set, it will never work. Explainable AI, it's special techniques. It helps us using multiple families in explainable AI, help us to find answer about why the model is acting in that way. Some of the most I love this method, which is the heat mapping, or they name it let's say leverage propagation, back propagation, something LRP. Now, what it's doing, it's back again from the output of the neural networks and back again, distribute the values until you reach the input. So according to the weights that trained, you can find in the input, which is, it was image, for example, where is the parts of that image giving you the output that you are expecting. So it's generate a kind of heat map. Now this heat map, it's tell you that, okay, at the center, at this part, if you are talking about classification about the horse, maybe the tail, it's tell you that this is horse because of the tail, for example. Okay, now this techniques, it will give you a clear, somehow clear, not 100% clear answer about why the model is acting this way. Once you apply these techniques, it's your model, it's become somehow explainable. That means you can give a reason, a cause about the output that you get. This is explainable in AI in general. Now there is multiple methods that following different techniques to perform the task. The most common one, the most common libraries is SHAP, which is using the SHAP values in game theory and make it applicable for any kind of, almost any kind of machine learning modeling. It will give you clear explanation that this is the most important feature for your task, and this is then, etc. And what is the correlation, if it's negative or positive correlation between the input and the output. The other method, it's called LIME also. This is the famous one, not the only, the famous one, but also there is many other methods. One of the simplest one, which is, for example, just a kind of imputation or kind of for unify, create a mask around the values, for example. If we are talking about image, use a gray mask for special place in the image and move it. And at the end, once the output it's changed, you can decide that this is the part of the image was the reason of the class. This is very simple way. It's not practical that much, but even this considered as explainable AI technique at the end. I hope this was clear.
Yeah, it's clear. Very, very well said, Guy. And so that's a whole it's a whole book or I mean, yeah, like a technology for explainable AI right now, or is this something new? Or
it's not right now. It's not considered new. Right now, it's only AI. It's going inside a lot of critical sectors.
Mm-hmm.
As you know, I'm working in the healthcare. Not only healthcare is critical, but even in the healthcare, once you want to trust a model that you build to perform kind of diagnostic model, for example,
mm-hmm.
that means, okay, it's not enough that the model is doing well. Maybe this, yes, exactly. So explainable AI, sometimes it's become a must.
Mm-hmm.
That means it's even by law, by the way, here in Europe, sometimes by law, we have to prove our models using explainable AI.
So this is more applicable to deep learning, right? Because you have a black box and it does all this back propagation and forward pass and all that stuff with using the weight stuff, right?
In general, it's applicable for all of machine learning algorithms. But yes, there is some algorithms, there is no need for explainable AI. It's somehow explained by itself, just like decision trees or random forest somehow. It's easy to find explanation about the results. Now in deep learning, no, you cannot at the end. So that's why the techniques is important. Yes, Ammar.
In addition to that, it is helpful and needed whenever we have structured data that cannot be visualized. So whenever we have like 2 features, we can plot them. But when we have 5, 10 features,
yes.
Yeah, it needs explanation, and the client usually has the right to make sure in a like a systematic way and not a testing way that this thing works, you know.
So when you have hundreds and hundreds of features, that's when explainable AI becomes relevant and important, or is it in a special case basis or special industry basis?
Both. You can consider both, and
Okay.
according to the industry and according to the case that you have. At the end, it's technique, and right now it's becoming better and better. There is new method are appearing, but the great about explainable AI, it's not about the final results. As I mentioned previously with Ammar, sometimes explainable AI, it will help us to know how to prepare our data in better way and remodeling once again. So it's helpful even for the let's say for us as a data scientist to maybe to have better understanding about the model and how it's doing that task. So I like explainable AI techniques a lot, and it's easy to explain when even when you are dealing with clients. It's very easy to show him, for example, a sharp chart that tell him, okay, just check this and you will understand what's happening. And really, it's simple because it's also for him no need to give a lot of explanation. Okay, this is what happened right now. So yes, it's helpful from practical point of view, but also it's helpful for us during our modeling process to use and rebuild once again.
Adding over this, this explainable AI thing could be the solution of the problem that I had within the model that I show you, that I cannot choose the best metric to assess my model, and those metrics, you know, accuracy, precision, recall, and F1 score, are a result of experiments and not explainability. Therefore,
Exactly.
When explainable AI matures and get systematic and clear, then we could say that now we have a new metric that is called explainable AI to assess our models, and we will not be stuck with accuracy and precision, recall, and those anymore.
Exactly. Yes, Ammar. Perfect. Any other question? Okay, since there's no question, let's wrap up now this session. Give me 10 minutes to join the mentoring. Today we have Donable. She will tell us more about SQL, which is something I like very much. And the great thing, even if Tom is not here, but the moderators, they are Kim and Magdi. So I will be relaxing in that session. See you in the mentoring.
Thanks, guys. See you later. Bye, guys.
Goodbye.
Thank you. Thank you.
Bye bye.